Okay, wrong problem. Here we go. If you're watching this video is going to probably be titled Using Substitution to Solve a Quadratic Exponential Equation, Example 2. Okay, so this would be the second video in this series. You'll definitely want to go back and watch the first video because I get into much greater detail about the how and the why of this process. I'm going to fast forward through some of that, okay, when talking about this one. So when you look at this problem, okay, it has three terms. Here's one exponential term, here's another, and then here's this one. Now keep in mind that when we're solving exponential equations, isolating the exponential term, right, is essentially our goal, because if we can do this, then we can log both sides and get that variable out of the exponent. But when you have exponential terms that have the same base but with different exponents, that complicates things, okay? So what we do is we identify, in this case, we have a three-termed expression with a floating constant. We look at this middle term and we see the variable term looks like this, okay? And if the variable term is e to the 2x, e to the 4x can be thought of as e to the 2x squared, right? Because what do we do with powers of powers? We multiply them. So in essence, this equation, and I'm going to write it all out again, okay? This equation takes the form of an even degree polynomial, or an even degree trinomial, should I say, that's set equal to 0. So really, this problem is not very different than a quadratic, where it would be x squared plus 3x minus 28 equals 0, right? It's something, and again, forgive the ambiguity or the general term that I'm using here, but it's something in the middle, that same thing being squared, right? This is something in the middle, and that same thing being squared, right? So I can approach solving this like I would approach solving this. One warning, right? Don't solve this for x, because when you do, you'll get answers that say x equals some number, and then you'll think you're done, but you're not actually done. Okay, we talked about that in the previous video. Go back and watch that again. So what I'm going to use is a different variable. I'm going to go off to the side and say this e to the 2x, which is, I'm looking at this and my head's spinning because there's a lot of stuff going on here. I'm going to call that a. So I have a squared plus 3 times a minus 28, and that equals 0. Okay, now this I can solve for a. And when I solve for a, like I've done before, I'm going to have two equations that a equals some number, which will mean this equals some number. And then I'll have my isolated exponential term. Okay, so here we go. An even degree trinomial. I'm going to try to factor this. I'm going to look for two numbers that multiply to be negative 28, but add to be positive 3. And those two numbers are, in no particular order, negative 4, positive 7. The zero product property says the answer from here has to equal 0, or the answer from here has to equal 0, which means a equals 4 and a equals negative 7. So I have my two values of a, then I bring this back in. So if a equals 4, it's actually e to the 2x, which is equal to 4. And over here, a to the 2x is equal to negative 7. So this is my isolated exponential term, right? I have two equations that I'm going to solve separately. In this first one, how do I solve for an exponent that is a variable? By taking a log of both sides. Which log do I want to use in this problem? Well, because the base of the exponent is e, the base of my logarithm should be e. That's a natural log. So I'm taking the natural log of both sides. And in doing so, the 2x comes down in front, right? Logarithms are the inverse operations of variable exponents. So we end up here. We know that the natural log of e is equal to 1. So I can evaluate that. 2x times 1 is 2x, which is equal to this. And then we divide both sides by 2. So my value of x is the natural log of 4 over 2. Please, 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 please don't tell me that this is the natural log of 2. I've mentioned this in previous videos. Whatever is inside of a logarithm is in a lockbox. I can't do basic operations with this number. Okay, I can't add, subtract, multiply, divide, square. I can't do anything to this if it's inside the log. Okay, so I have to treat, and we've said this before as well, treat this logarithmic package as a number, right? So we're dividing that number by 2. It just looks like this. So this would be the logarithmic form of my answer, okay? And then we can get a decimal approximation for that by plugging it into a calculator. I'll let you handle that on your own, okay? Same approach to this problem. Now, when I take the natural log over here, things get weird, right? The 2x still comes down in front, and I have the natural log of e equals the natural log of -7. And tell me, what power can I raise e to and get an output of -7, right? This has no solution. We're not allowed to take the logs of negative numbers because you can't raise a positive base to a number and get a negative number out. That's impossible. That's why we can't take the logs of negative numbers. So this piece has no solution. We can write that, but really when we express our solution, we just don't even mention it, okay? Our only solution is what we get from this equation over here.